Hello student, today we are going to start the normal probability distribution. The normal curve with mean mu and standard deviation sigma is 1 upon sigma root 2 pi into e raised to minus x minus mu whole square upon 2 sigma square. Means by using mu and sigma we can draw such type of graph or curve which is known as normal curve. In this normal curve, along this side it is z and here it is a f of z. So what is this z? So probability of z, it is a p of z, that is equal to area under the normal curve. For example, the value of z equal to 1.2. So here it is 0, here supposed to be 1 and 1.2. So area from 0 to 1.2, this area is nothing but the probability of z. So what is probability of z? Area under the normal curve. So how to find this normal curve? By this formula. So normally in exam they will provide the value of area, means for a particular z value the corresponding area they will provide. So now probability of z, it is nothing but p of z, that is equal to area under the normal curve. But given value is x, means we have to find probability of this x. So that x you convert into z by this formula. So which is this formula? Z equal to x minus mu by sigma, where mu is mean and sigma is standard deviation. And therefore probability of x, that is the p of x, that I will convert into z by using the formula x minus mu by sigma. And once we get a z, so I can consider the area under the normal curve. So this is a normal curve table. It means that corresponding z value will get the area. So for example 1.1, so this value is there 0.3643. So this type of table you can find in book, but in exam they will provide the corresponding value of z and the area. So let's consider some example on this normal distribution or normal probability distribution. So here is one example. Suppose heights of students follow normal distribution. So note that whenever in example normal word, we have to use normal probability distribution. So suppose heights of students follow normal distribution with mean 190 centimeter and variance 80 centimeter square. In a school of 1000 students, how many would you expect? It is, here is the expect, to be about 200 centimeter tall. Given A1, here value is given z is greater than 1.1180 equal to 0.13136. A1 means it is the area. First you write given. So what are the given things here? So in a school 1000. So total number of students 1000. Mean means mu, that is equal to 190 centimeter. And variance, note that here variance is given, not standard deviation. So variance, it is nothing but sigma square, standard deviation square, it is a 80 centimeter square. So what is the standard deviation? That is sigma, it is a root of 80 centimeter. So what we want to find, how many would you expect to be above 200 centimeter tall? So probability of student having heights above 200 centimeter. So therefore what we want here, so here x is greater than or equal to 200. So what we want here, probability of x which is greater than or equal to 200. So that you convert into z. How? We know probability of z which is greater than or equal to 200 minus mu by sigma. So this value of x I will convert into z by using the formula x minus mu by sigma. So that is equal to, so what is this? Z is greater than or equal to 200. What is the mean value? Given mean value is 190 centimeter upon sigma is under root of 80. So find this value. So probability of z which is greater than or equal to, so it is a 1.11. So by calculator you find this value. So note now, Z is greater than or equal to 1.11 and we know probability of Z is area under the curve. First you just consider this is a normal curve. Now in this case, what is the value of Z? Z equal to 1.11. So whenever Z equal to 1.11, I am getting the area from 0 to Z, means this area is I am getting, right? But in this case, Z is greater than or equal to 1.11 and given area, this Z is greater than 1.1180. So actually that value I am getting by calci 80 also there. So Z is greater than or equal to 1.1180. So this value is given. See here, what is this area? So that area is what? 0.13136. So it is the probability of X having height greater than or equal to 200 centimeter. So total number of students. So therefore total number of students having heights above 200 centimeter equal to that probability we got 0.13136 into 1000 students. So I am getting here 131.36 means 131 students. So the total number of students having heights above 200 centimeter are 131. How many students we expect having heights above 200 centimeter? So 131 out of 1000 students. So which is your required answer. Consider the another example. Example, in a certain examination test, 200 students appeared in a subject of statistics. Average marks obtained were for 50% with standard deviation 5%. How many students do you expect to obtain more than 60% of marks, supposing that marks are distributed normally? So normally, this word is there, it means that we have to use normal probability distribution. And given area corresponding to Z equal to 2. See the difference between this and last. Here Z equal to 2. It means that whatever the area, it is from Z equal to 0 to 2. So Z equal to 2 is 0.4772. So first you write given things. So given total number of students 200. Now average marks mean mean. Average marks means mean value. That is a mu equal to 50%. 50% means 50 by 100. It is 0.5. And standard deviation, that is a sigma. 5% means 5 upon 100. So I am getting it is a 0.05. So what we want to find, how many students do you expect to obtain more than 60% of marks? So probability of students obtain more than 60% marks means what is the value of X here? 60% means 60 by 100 and that is equal to 0.6. So we want that is a more than that. So X is greater than or equal to 0.6. You convert into Z. How? So Z is greater than or equal to X means 0.6 minus mu by sigma. So that is equal to probability of Z greater than or equal to 0.6 minus mean value is 0.5 upon 0.05 standard deviation. So find this value by calculator. So I am getting Z is greater than or equal to 2. So what is the value given? Area corresponding to Z equal to 2 is given. First you note the normal curve. See there, here the normal curve. Here Z, along this Z and along this axis it is f of Z. So Z equal to 2. So I want this area. I want this area. But given area is what? Z equal to 2. It means that 0 to 2 it is given. So that is why, how to find it? You know, total probability it is a 0.5 from 0 to infinity and minus infinity to 0 it is a 0.5. So that is why the same thing I can write left hand side X is greater than or equal to 0.6. So I got that is the probability of Z greater than or equal to 2. So by figure, I will explain it. Z equal to 2. We want this area that is equal to. In exam, need not to draw these figures. Only one figure is sufficient. What is the given thing? It is a 0 2. Z equal to 2. So first, so here total is what? 0.5 means this. So it is a 0.5 total area. When we subtract this area from 0.5, so I will get the required is this one. So from this I will subtract this part. When we subtract, supposed to be this part, so remaining part is this one. So same thing. So again I repeat, that is need not to draw such type of figures in exam. Here only for the understanding. In exam one figure is sufficient, and the same thing I can write like this. It is equal to 0.5 minus probability of Z equal to 0 to 2. Same thing I can write 0.5 minus probability of Z equal to 2. Probability of Z equal to 2 is given. So that value is 0.4772. So I am getting this value. Left hand side is probability of x greater than or equal to 0.6, that is equal to, it is a 0.0228. So this is the probability of students getting more than 60% marks. So total number of students here 200. So multiply. So total number of students expect more than 60% marks. That is equal to 0.0228 into 200. So I am getting here 4.56. It means that near to 5. So total number of students expect more than 60% mark. 5 students, which is your required answer. So next example, a random sample of 200 screws is drawn from a population which represent size of screws. If a sample is distributed normally with mean 3.15 cm and standard deviation 0.025 cm, find the expected number of screws whose size falls between 3.12 cm and 3.2 cm. Area corresponding to 1.2 is given 0.3849 and area corresponding to 2.0 is given 0.4722. Actually here is the printing mistake. Actually this area is a 0.4772. But in exam supposed to be it is a print mistake. So whatever the value is given, you have to consider the same. Here we are doing a practice, that is why I am taking the correct value. But again I repeat it, if whatever the value given in exam or in question paper, same value you have to use in calculation. So solution here, given things you write first. So total number 200, given mean you read carefully and you will get here mean mu, that is a 3.15 centimeter, and standard deviation, that is nothing but sigma, it is a 0.025 centimeter, and find the expected number of screws whose size falls between 3.12 centimeter. So probability of screws whose size between 3.12 centimeter and 3.2 centimeter. Means here given value of x is what? 3.12 is less than or equal to x is less than or equal to 3.2. So that probability we want to find. So I will write here probability of x means 3.12 less than or equal to x less than or equal to 3.2. You convert into z. So what is the formula of z? Z equal to x minus mu by sigma. So x is what? 3.12 minus mu by sigma. Less than or equal to, now it is in z. So 3.2 minus mu by sigma. So put the values of mu and sigma. So I am getting probability of 3.12 minus 3.15 upon sigma is 0.025. Less than or equal to z is less than or equal to 3.2 minus 3.15 upon 0.025. So by calculator you find this value. So I am getting that is equal to probability of minus 1.2 is less than or equal to z is less than or equal to 2. So by graph or normal curve you can understand what is this actually. So here is this normal curve. So here z equal to 0 because z is along this, z equal to 2 here, and in negative direction minus z equal to minus 1.2. So we need this area, right? But normally area z equal to whatever the value we are going to consider from 0 to, and that is why same thing I can write as the area, it is a minus 1.2 to 0 plus probability of 0 is less than or equal to z is less than or equal to 2. So first I will consider this area minus 1.2 to 0, and after that 0 to 2 this area whatever there. Again one thing is there, it is a normal curve, it is a bell shape, and that is what whatever the area this side is same area, it is symmetric about y-axis. So that is why whatever the area from minus 1 to 0, see there, it is the area from z equal to minus 1.2 to 0 supposed to be here, it is same, and that is equal to same as 0 to 1.2 positive. So by using this I can write probability of minus 1.2 to 0 is same as 0 to 1.2 because it is symmetric. So whatever this side 1 point minus 1.2 same is 0 to 1.2 plus probability of 0 to z, z equal to 2. So both values are given. Area corresponding to 1.2, it means that 0 to 1.2 it is 0.3849, and z equal to 2 it is a 0.4772, and therefore the probability of 3.12 is less than or equal to x is less than or equal to 3.2 left hand side, and the right hand side is addition. I am getting 0.8621. So total number of screws here 200. So expected screws equal to 0.8621, that is the probability in between sizes 3.12 to 3.2 and into 200. So I am getting the number 172.42. It means that approximately 172 screws expected, whose size between 3.12 to 3.2, which is your required answer. In the next video we will consider more examples on this normal probability distribution as well as binomial and Poisson's probability distribution.